Hello and welcome to another week of Labrats. So last week we learned about the scientific method, and the scientific method is coming up with a question and then coming up with a hypothesis about that question and then testing it and coming up with a conclusion. So in our example, we took two really common household ingredients, which is borax and glue, white glue, and we asked if we combine these two, will it create something new? And so we had our hypothesis that we predicted it would create something new. We combined those substances and we made slime, which is a completely different substance than both of those on their own. So we were able to determine that yes, our hypothesis was correct, and therefore we understand the scientific method. So this week we're doing a little bit of a concept building exercise. It is an experiment, but it's more about the concept of what exactly matter is. So in order to understand science, we need to understand matter. Matter is anything that has mass, so it has some weight to it, and it takes up space. So that is literally everything, not only on planet Earth, but in our entire universe. It's the air around us. Even though, air is invisible, it still is occupying space, and it has some sort of mass, even if we can't detect it here on Earth in our human physical form. This table has mass and takes up space. The trees around us, the lakes, the water, that all has mass and takes up space. So there are a number of substances that can go between three different states of matter. So there are three different states of matter, and they are all made of atoms. And atoms are just the tiny, tiny, tiny microscopic particles that make up everything in the world around us. Even though we can't see them, they are there. So they make up this table and everything else that I just explained to you. So atoms make up three different states, and those states are a solid, a liquid, and a gas. And a really great example of this that we can use in our common everyday life is water. In its solid form, water is ice. In its liquid form, water is water, as we would like drink. And in its vapor form, water can be in the air and in our lungs and everywhere else. So water is really one of those easy examples that we can use to understand what a solid, a liquid, and a gas is, and how a lot of substances can basically change in between all those different states and change back and do all different kinds of things. So as a solid, all those tiny little atom particles, they're just really, really tiny and they can't move very easily. And in a water, those particles are able to move more freely, which is why you can pour water and it doesn't behave the same way as a solid. And in a gas, those particles are able to move a lot more freely, and they expand, and that's why, water can be a vapor in the air that we can't see with our naked eye. So it's really that these particles, how they move as they go between that solid, liquid, and gas stage. When they're a solid, they can't move. When they're a liquid, they can move more freely. And when they're a gas, they can float around and be as free as they want. And that's essentially what's going on here. So I gave you 3 balloons. 2 of them I wanted you to fill with water. 1 of those 2 I wanted you to freeze. So I've already done this. And I've taken the balloon off of this so we can see water in its solid form. This is water as a crystal, which we call ice. And it might seem crazy that this is actually a crystal, but it is. It's just that water at the temperature that we experience here on Earth can really easily go between its 3 states. Not like gold, say. Gold can't do that. Gold wants to be a solid all the time because it has to be heated to 1500 degrees to turn into a liquid, which we obviously can't do on the surface of the Earth unless we have like special burners, in a lab or something to melt it. And to be a gas, gold has to be heated to 2000 degrees. So obviously that's really, really crazy. So that's why water is a really good example of something that can change very easily between a solid and a liquid and a gas. So this is a balloon that's filled with water, and you can kind of see that, yes, it flows, we can shake it, we can manipulate it, and then we can also experience water as a vapor or as a gas. So if you blow up a balloon, we have actually trapped water as a gas inside of this balloon. So if any of you have ever, put your breath against a cold window pane in the wintertime and you've noticed that it changes to frost, that is actually water vapor from your lungs hitting that glass pane and instantly becoming a solid because it's cold enough to drop into its solid state. So this is an example of how how a single substance of water can be easily changed into different states depending on what's happening to it, how hot it is, what its environment is like, it changes. So as a solid, solids are cold, basically. So they contract, they become smaller. As they become warmer and change into their liquid form, all those little tiny atom particles expand, they become bigger. And as they expand into water, or into water vapor, they expand even more. So there's very little water vapor in this, but it's occupying so much more space, right, compared to this. And there's water inside of this, but there's more ice here, and it's occupying less space because it's cold, right? So cold things occupy less space, even though there might be the same amount, is basically how it works. So I'm sure that we've experienced something, you know, like a rock, right? So you drop it in the water and it drops to the bottom because it is in its solid state. So it wants to fall to the bottom in a glass of water. But water in its crystal form, or in its ice form, in its solid form, wants to float on top of its liquid form. So next week we're going to explore this, because I don't, you know, does this make sense that the solid form of a material wants to float on its liquid form? I can already tell you that's very strange, but it's the entire reason why life is possible on Earth. If water didn't behave this way, life would not be possible. So that's what we're going to explore next week, is how exactly these states of matter actually make life on Earth possible. So tune in next week, and if you have any comments about this video, put them down in the bottom, and I'll see you next week.